Request, a small-scale multitask model for community question answering systems. This research is part of a PhD thesis in the graduate program of the Text Retrieval Research Laboratory at KN2C University of Technology. Over the last couple of decades, community question answering (CQA) platforms have gained prominence as reliable places to acquire knowledge. Stack Overflow, Yahoo Answers, Quora, and iClinic are 4 examples of CQA platforms. CQA allows information seekers to post their questions in natural language with any amount of peripheral details and then receive descriptive answers from human experts. Nevertheless, many questions may remain unanswered forever or may not be answered immediately. This issue may arise from the proliferation of newly arrived questions, too long or ambiguous questions that fail to appeal to relevant experts, improper categorization of questions or users, and the like. Hence, researchers have strived to enhance CQA platforms from various aspects and make them more efficient. The first solution is recognizing question entailment, abbreviated by RQE. According to the definition provided by Abacha et al., an entailment relation from question Q to P implies that every correct answer to P is either a complete or incomplete response to Q. Indeed, when a new question arises and most of the experts are busy answering other questions in the community, we can get help from the community archive of resolved questions. In this way, RQE empowers CQA platforms to automatically answer an input question by quickly finding semantically similar questions, re-ranking the corresponding answers, and selecting the top ones. Therefore, it saves both the waiting time of the question asker and the effort of the answerers. The second solution is question summarization, abbreviated as QS. As millions of new questions are posted on CQA platforms daily, it is almost impossible for community experts to review them all manually. Moreover, most questions are multi-sentence and complex with unnecessary details, making it hard for experts to quickly discover the intent of each question. Automatic question summarization is the process of generating an abridged form of the input question that encompasses its overall meaning. Hence, experts may use a summarization system to quickly discern the key concepts of questions and decide whether to answer or skip them. In CQA platforms, the algorithm aimed at predicting the most suitable expert, who can provide an accepted answer for the target question, is called question routing. Most existing approaches predict users' expertise based on their past question answering behavior and the content of new questions. However, in the absence of exclusive topical tags, it is hard to identify pertinent experts. In this regard, the third solution for improving CQA platforms is question tag generation, abbreviated as TG. Tag generation involves generating a set of descriptive words for a piece of text. TG could help route new questions toward potential respondents whose expertise is related to at least one of the tags generated for the question. It would also be possible for CQA platforms to determine users' expertise or favorite topics by analyzing the tags generated for the questions they asked, answered, or viewed. The success of multitask deep neural networks in NLP tasks motivated us to devise Request, a small-scale multitask model based on encoder-decoder transformers. It simultaneously recognizes question entailment, summarizes questions respecting given queries, and tags questions with primary topics. The design of Request is influenced by multiple considerations. Firstly, while transformer-based question summarization models are adept at fluency, they often lack factual correctness, prompting the integration of question entailment for logical entailment assurance. Secondly, generating concise summaries necessitates a greater focus on main topics, a gap addressed through joint learning of tag generation and QS, leveraging tags as key indicators for the main topics. Lastly, the complexities faced by RQE models, such as lengthy questions and lexical heterogeneity, could be addressed by engaging QS and TG to compress and simplify questions into abstract versions conveying essential information. Request offers distinct advantages over competing alternatives. First, it is versatile across different domains, not relying on any domain-specific data source, knowledge, or ontology. Second, it treats tags as coarse-grained summaries and generates them with sequence-to-sequence generative models, unlike prior research that used discriminative models, allowing it to generate any number of tags without ever seeing them before. Third, sharing layers between tasks resulted in fewer learning parameters than transformer-based rivals. Moreover, to the best of our knowledge, this is the first study that learns TG and RQE simultaneously with abstractive summarization, prioritizing brevity of summaries. Note that it supports query-focused abstractive summarization. The good results of bidirectional auto-regressive transformer, abbreviated by BART, on abstractive summarization benchmarks compared to other encoder-decoder models motivated us to use it as the backbone for the proposed model. BART follows the general sequence-to-sequence transformer design, so that the input sequence serves as input to a bidirectional encoder component, while the decoder generates outputs in an auto-regressive manner. There are two versions of BART, namely base and large. There are 6 layers in the encoder and decoder components for the base model and 12 layers in each for the large model. In this research, the BART base variant is utilized. More specifically, request comprises 1 BART encoder representing input sequences, 2 BART decoders reconstructing summary or tag sequences, and 3 neural network heads generating task-specific outputs. In the RQE task, a BART encoder and a multi-layer neural network work to minimize binary cross-entropy loss between target and predicted class labels. Notably, the decoder component is eliminated from the RQE task, resulting in a substantial reduction in parameters without degrading performance. The second task, QFQS, contains the same encoder accompanied by a decoder and a linear head. Indeed, sharing the encoder is anticipated to enhance text representations via multitask learning. During training this component, the cross-entropy loss, computed based on reference and generated summaries, is utilized. Task 3, known as TG, shares components with QFQS but with distinctions in the last decoder layers and the task-specific head. In a collaborative effort, TG and QFQS work together by leveraging the first L1 layers of the decoder in addition to the shared encoder. The goal is twofold. TG aims to guide the shared decoder layers towards emphasizing on keywords and generating concise sequences, while QFQS focuses on directing the shared decoder layers to attend more to meanings. Meanwhile, the presence of independent decoder layers allows TG and QFQS to pursue their respective task-specific objectives autonomously. All trainable parameters in TG are fine-tuned by optimizing the cross-entropy loss between the target tags and the generated sequence of tags. During training, after a round of forward pass, a weighted sum of losses from all tasks is used to update the trainable parameters in the shared encoder component. Following the completion of the second forward pass, shared decoder layers are optimized by incorporating losses from TG and QFQS. Finally, task-specific parameters are fine-tuned by backpropagating their respective losses. Bear in mind that all coefficients are real-valued hyperparameters. The proposed method undergoes evaluation across 4 diverse datasets. Among these, MediQARQE, MeQSum, and Debitopedia are publicly available, while CQADREQUST is a dataset we developed in this research by extracting the necessary information from an existing dataset named CQADupstack. On the small variant of CQADREQUST, we have assessed the efficiency of simultaneous learning of multiple tasks compared to single-task learning. System number 1 fine-tunes shared encoder parameters exclusively for the RQE task. System number 2 updates QFQS-related parameters based on the QFQS task loss. System number 3 considers only TG loss for relevant parameters in the TG task, while system number 4 follows the main idea of request, that is to adjust all trainable parameters with the simultaneous contribution of all tasks. The observations reveal that the multitask model outperforms individual models despite reducing the number of trainable parameters significantly. Further, the general attitude of most plots is increasing, underscoring the positive impact of RQE on TG and TG on QFQS through latent interactions. In another scenario, we analyzed the sensitivity of request to changes in coefficients, aiming to identify the optimal combination that yields the highest performance across all tasks. The performance of request in the RQE task appears to be relatively independent of the exact tuning of coefficients, as all systems eventually converge to stable F1 scores. Regarding the QFQS task, our results indicate that all systems have the potential to converge to efficient results, although some do so faster than others, and some require more time. Specifically, upward trends in BART score and Rougeol results suggest that semantic similarities are well preserved in all systems. Moreover, the broader range of Rougeol values denotes that systems adhere more to semantic than lexical similarity, which is coherent in abstractive summarization. A similar analysis can be conducted for the TG task based on BART score and Rougeol results. Results obtained from the test data also confirm this argument. Continuing, we repeat this analysis on the large version of CQAD-REACH-UEST. The evidence supports the claim that request performs all its tasks fairly well and implies that the data distribution in the small version of CQAD-REACH-UEST is sufficiently homogeneous. On the MediQA-RQE dataset, request outperforms even BioBART, highlighting the critical influence of text representation on classifier performance. For the MEQSUM dataset, request surpasses BART, Pegasus, and their ensemble model, demonstrating superior BRT score and Rouge metrics, indicative of well-generated summaries that convey the meaning of target sentences. Indeed, the multitask learning approach proves effective for the QS task, with the potential for further improvement through the incorporation of domain-specific information. On the Debitopedia dataset, request excels in Rougeol, recovering a significant fraction of reference tokens in the same order, and also achieves a notable 90% BART score, showcasing high semantic quality in captured reference tokens. We can conclude that 1. Request, a compact transformer-based multitask model, optimizes RQE, QFQS, and TG output quality through latent interactions. 2. Treating the TG task as a summarization task at coarse granularity, and joint learning with RQE and QFQS, improves its performance and positively impacts QFQS. 3. Request's performance is almost independent of hyperparameter initial values, ensuring stability. 4. Despite significant parameter reduction, request outperforms other transformer-based rivals. 5. Request demonstrates generalizability across diverse datasets and domains. In future work, we will address the following enhancements to the current study. 1. Assessing the effectiveness of other transformer models such as Longformer, T5, and DistilBART. 2. Identifying the best composition of coefficients by implementing an ML-based model. 3. Defining larger values for coefficients beyond the range of 0, 1 to accelerate convergence. 4. Defining Rouge-based objective functions instead of cross-entropy loss to better match the problem objectives.